Chapter 2, Graphs, Charts, and Tables, Describing Your Data. In this video, we'll be focusing on how to create a line chart and scatter diagram. So a line chart is a two-dimensional chart showing time on the horizontal axis. So here we see years as my time, and the variable of interest is on our vertical axis. So here our variable of interest is the number of mobile homes sold. Line charts are used to display time series data. Recall in Chapter 1 that time series data is a set of successive data points over time that's been collected. Such data is helpful to see trends over time. So as you can see here in this chart, the trend is moving upward, meaning that as the years progress, more and more mobile homes are being sold. To construct a line chart, our first step is to identify the time series variable of interest. So here, our variable of interest is the number of mobile homes sold, and you will, in step 2, construct the horizontal time and vertical, our variable of interest, axes. So in our table that will turn into the chart, so you can see our years starting from 2003 up until 2012, and below each year is the number of mobile homes sold. In step 3, we can then plot the points of the graph and connect them with straight lines. Now you can do this by hand, but we typically use Excel to do this. A scatter diagram is a two-dimensional graph of plotted points in which the vertical axis represents a value of one quantitative variable and the horizontal axis represents values of another quantitative variable. Note that both variables have to be quantitative or numeric in nature. Now, which variable goes on which axis, though? So if we look at the y-axis, this is our dependent variable. So these are values that we think are a function of or are dependent on another variable. That other variable is our independent variable, which follows the x-axis down below. These are the values that are thought to impact the values of our dependent variable. We'll look at an example shortly. Now, we'll learn more about this in Chapter 14, but in this chapter, we're really just focused on how to create the charts and what they're used for. So scatter diagrams help us see potential relationships between two quantitative variables. So as you can see in charts A and B, these are linear in that when I plot my x and y dots, I can imagine a line that crosses through them. In chart A, it's a positive linear relationship. As x increases, y also increases. Whereas in chart B, this is a negative linear relationship. So as x increases, y actually decreases. In charts C and D, these are curvilinear, which are not covered in this course. And then charts E and F display no relationship. In other words, our dots randomly appear on the chart. Now, to construct our scatter diagram, we want to identify our two variables of interest. And remember, they have to be quantitative or numeric. Now, in step 2, we want to make sure we understand which one's the dependent variable, that's going to go on our y-axis, and which one's our independent variable, which is going to go on our x-axis. So it's helpful to think about this story of ice cream sales. What we believe is independent is the weather temperature. And so here we can see the temperature in Fahrenheit. And what is our dependent variable, or what might be impacted by our independent variable, is our ice cream sales in thousands of dollars. Now in step 3, we want to make sure our scales in our axes make sense. So as you can see in our x-axis for our independent variable, our scale is every 10 degrees Fahrenheit, from 60 up to 120. And for our y-axis, which is our vertical axis, the scale in terms of our ice cream sales in thousands of dollars is also in increments of 10. In step 4, taking actual data that we have, we will go ahead and plot the joint values by placing a dot in the x and y space. So for instance, one data point might be on a particular day where it was 80 degrees Fahrenheit, we sold approximately $59,000 in ice cream sales nationally. As we plot all of the dots, we can then, in step 5, interpret the relationship. So we can see here, it looks like there's a linear relationship, so I can imagine a line crossing. So as it gets hotter or our temperature increases, so does our sales in ice cream. The last chart I want to point out is something called a Pareto chart. And it's a special type of bar chart. So while you learned how to do a bar chart in a previous video, this is applying something called the Pareto principle. So this is an 80-20 rule that's often used in quality. So if you're ever interested in going into manufacturing or becoming a quality manager someday, this is a useful tool where quality managers will use statistics to understand what's going on in the workplace. So for example, a company tracks causes of machine downtime and the minutes of downtime associated with each cause. So here we're going to present our data as a Pareto chart. Here in the table, we've collected the reasons that our machine breaks down, such as a broken belt, an electrical issue, operator or human error, maintenance, waiting on materials, or a miscellaneous bucket. We also track down the average number of minutes of downtime for each category. So once we sort our data, we will display the chart in descending order. So the reasons with the most amount of downtime appears first and then goes down from there. That way we can focus on fixing the biggest problems or the biggest impact, because typically we do not have time or resources to fix every single issue. It is more impactful for us to focus on waiting on material and maintenance issues versus addressing electrical or broken belts. So that's one way to apply the Pareto rule to a bar chart. If you have any questions, just let me know.